Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to make an ASP calculator, or a web page that performs some calculation functionality. So, we're going to start by creating a new project. It'll be a C# empty web application, and I'm going to call it Calculator Demo, and store it on my desktop. Having created our solution, we can see that we have our Calculator Demo project and with a web config, and pretty much it's empty at this point. I'm going to add a class, and I'm going to call this class Calculator. This calculator class will be used in order to do all my calculation functionality. And assuming that you've already learned how to write classes in C#, I'm going to just paste in an existing calculator class that I've created. Looking at this, we can see that I'm using XML commenting, so you can see the triple slashes here. This is particularly important when you're using or particularly useful when you're using a class to model some functionality that you want, because as we'll see later, these comments will actually show up in the IntelliSense when you instantiate instances of your class. So I recommend using XML comments. The other thing I recommend using are region fields here, and primarily because we can collapse these fields and it makes it easier to find things in your class. We can see here this calculator class has two number fields, which are doubles, and an operation field. And up here I've set it so that it defaults to the plus operator. Under I have a couple properties in order to provide access to these protected fields. You could make these private as well, but since this class might be a nice one to extend, I made everything protected instead of private. So we have properties for num1 and num2. Notice that I call the calculate method from my set methods, my properties. And we have one for the operation. Again, we call calculate because anytime I change the numbers or the operation, it should change the result. And then we have a read-only property for result. Note I made the set private here, and same thing with this divide by zero boolean, which will return true if there's a divide by zero error. So you can check this to make sure that you have an okay result before you use result. And I put that note in here so that in IntelliSense we will see that. Finally, for methods, I just have the calculate method, and all it is a switch operation. It looks at the type of operation and then calculates the result. So that's our calculator class. Next, I'm going to add a web form. And I'm going to call this web form, let's see, calculator page. My web form then gets created and stubbed out. We know, so we have a .cs, which is the code behind page. We have the designer.cs, which is the second part of the partial class associated with the .cs file, and that will be auto-generated by by Visual Studio, so I'm going to close it and not touch that. I'm going to call my web page SuperCalc 3000 because that makes it exciting and people will want to use it. Add some a heading. Hit Control F5 just to see what that looks like. And then start making a calculator page. So we need 2 text boxes to input our information. And I'm adding it directly in the source page, but you could also work from the design view. And probably a couple labels would be nice. So I'm just dragging them, and you can see in the source view, here we have the labels. Use some descriptive names so you can find them. And I think I like this better, first number or second number. Notice when I hit some spaces, it threw in some non-breaking spaces. It'll automatic, if you don't want to type in all the HTML code, working from the design view can make things a little quicker. And then we're going to need a label to show the results. We don't need the text property on our number labels because we put it in the inner text. And we'll also need some buttons. And we'll need 4 of them for each of the different types of operations. And if I change the text property of the buttons, that's what will actually be displayed. And probably a couple of non-breaking spaces between each one of those will make it look a little better. So we'll steal some of those. Okay, not bad. And then these buttons I'd like to style a little bit, so I'm going to add an inline style sheet. I'm going to create a class called mathBTN. And we're going to use that to set the height and width. And we're going to set the button CSS class property equal to math button. And notice that because that's the only style that's available, really, there's no page yet, CSS page yet, IntelliSense will tell me what classes I can apply currently to the CSS class. So pay attention to IntelliSense as it comes up. And I'll just copy this attribute over to the other buttons. And let's see what it looks like. So the buttons are a little bigger. Obviously you can do a lot of styling to make this page look a lot better, but that should work. So the next thing we want to do is create event handlers for each of these. So I'm just going to double click on each button, and to do the calculations, since I already have a calculator class, so I'm going to instantiate a calculator, and then I'm going to say cc.first, or number 1, is equal to, and txb num1 text, but of course I need to convert that text to a double. So we could do that with by declaring a double. Or we can do that with a float dot parse. Actually, we want double dot parse. And because I'm using that, I could create a exception. So I'm going to enclose this in a try-catch block. And in my catch, I'm just going to say label LBL results is equal to continuing on, get the second number, and then for the operation, first we'll implement the plus operation and just verify, and LBL results.text is equal to cc.result. And you could do some formatting on that result if you wanted, but this should take, we instantiate a calculator class object, then we set num1, num2 in operation, and then the results of that operation will be placed back in the text box so the user can see it. Let's see if this works. So I'm hitting Control F5. Here's my calculator page. 4, 5, I hit the plus, and I get 9, so that works. If I put in some garbage, I get an error. So this is working. Now we need to do the other operations. Well, what would be nice is if rather than having to write multiple event handlers, what if I just said, made a generic button click event, and from my page, if I look at the properties and I look at the event handlers, I'm going to pick that one. Let's make sure that that still works because I changed the name. That's working. And now we just need to change all these buttons to pick the same event. We'll test that. And these are working, but they're just doing addition. So we need to do some more logic with our calculator. What we need to do is figure out which operation. Well, conveniently, the symbol that's in the text box or in the label, it can be used here. You can, and this is something where you might do it kind of creatively. But we need to take the sender. Currently, sender comes in as an object, so we need to cast sender to button. And we can do that very simply by doing a casting operation. Now, often it's not bad practice to put an if sender is button, and this will make sure that before you cast something, you probably want to verify, and usually you would log error here, and you wouldn't really display it because this would be some kind of, it would probably be something that happened with the code later on. Someone came back in and changed things. And so this if then doesn't really do much. We don't anticipate it ever being called really, but it does protect your code. If you're in a habit of casting things, always check beforehand. And then what we can do is, now that we have a button object, we can set the operation to btn dot, the text property should work. Because if I look at my calculator page and my source, we can see text here for each of these buttons is plus, minus, asterisk, and slash. So this is one way of figuring out which button it is. The other way is you could use a switch statement and look at the ID of the object being sent in, and that might apply for situations where you don't conveniently have the text property being the exact value you need for that class. So there's a number of different ways of solving this problem. This is just the one I'm choosing for this particular application. And let's see if we got this to work. So if I divide 55 by 5, I should get 11. If I multiply it, I should get 275. Okay, and if I subtract them, I should get 50. So all of these are working. But what happens if I put a 0 in and I divide? I probably should be getting a divide by zero error. And it turns out that the class I wrote by default um, will, when it does, rather than provide an infinite or anything like that, it will return 0 when you divide by 0. So that's probably not very accurate. Any mathematicians would tell you that that's actually dead wrong. So what we need to do is, because it does have that Boolean in my calculator class, this one right here that returns whether or not there's a divide by 0, what I can do is I can check that. If cc.divide by 0, then I'm going to display otherwise I'll do the result. So I check to see if there's a divide by 0. If there is, then I'll display that. Otherwise, I'll display the result. So I'm going to save this, and let's see if that worked. 5 or 55 or 550, that'll be fine. I hit it gives me a divide by 0 error. The other ones will of course do what they need to do. They won't produce a divide by 0 error, and if I put a 5 or 2, then I get the correct result. So now my calculator is actually working. Now there's a lot of testing we did, and what happens is that if testing that works great, but once we put this page into the code base, what happens if later on someone changes something and it makes it not work? It'd be nice to have an automated testing capability to make sure that the calculator class still works. So we're going to add a unit test project. And the way you do that is you right click on the solution, and we're going to add a new project. And if you look at C# test, there's unit test project, and I'm going to call it calculator demo test. So I just take the project name and add test. There's probably different ways you can organize your test projects. You can have multiple test projects and associate them with each class, or you can have each project associated with each project in your solution. But the way I'm doing it is I'm just going to have one test project for each project in my solution. And once you have a test project, what you have to do is add a reference to the project you're going to test into the test project. So the first thing I want to do is click on references, add reference, and if you have different options. You can look at assemblies when you add references. You can look at solution, which will list all the other projects in your solution, and that's what we're going to use. There's also you can also browse to the specific file, but for us in this case, using solution and pointing to the calculator demo project is probably the best way. Now that we have that reference, we can then use the classes that are in the calculator demo class in our calculator demo test project. And you notice that when you create a unit test, it stubs out a unit test class for you. I'm going to rename this, and I would have one test class for every class that you have in the project. And I'm going to call this one calculator test. That way I can associate this class is associated with this test class. And click yes on when it says, do you want to refactor? And you notice that there are the attributes associated with the objects in these classes. And the reason why you have these attributes is Visual Studio will use these attributes for the methods and classes in your test project to identify them as such, and that's how it knows to run those tests every time your project is, or every time you ask it to run all the tests. And so we have our test class, calculator test, and then we have a method, and normally we rename the methods to some kind of requirement. And so in this case, one way of testing it is just I'm going to start off with just the basic addition testing. I'm going to say should add 2 plus 2. And the normal structure we do this is I'm going to instantiate a calculator, but in order to instantiate it, I need to add a using statement. So I'm going to say using calculator demo. Because I have a reference, I can now find it in the using statements. And so now calculator demo is included as a reference or as a in the calculator test.cs. And I'm going to instantiate a calculator because we need it to test it. And I'm going to set number 1 equal to 2 and number 2 equal to 2. It's not going to be a very interesting test, but tests don't have to be interesting. They just have to cover all the instances. So this will test the addition functionality. And I'm going to and typically we will create two variables, one called expected result, and I expect it to be 4, and I want to specify it implicitly. I don't want to calculate it using CC. I want to do my own work by hand maybe, or using Excel, and figure out what I think the expected result will be. I did this one in my head, 2 plus 2. My education extended far enough that I can actually figure that one out. And then the actual result will actually be calculated using the class that's under test. In this case, I'm taking the CC class we created, and I'm saying actual result is going to be the result from that. And next we're going to use the assert class. The assert class is a class that comes with Microsoft's test functionality or API, and basically an assert, there's a number of assert methods, are equal, are not equal. You pick the one that is null or is not null. You pick the method which will test what you think the relationship of the expected result and the actual result should be. So in this case, I'm going to use are equal, and you notice that first we put the expected, so expected result, and then next we put what the actual is. And what this will do is whenever we run a test, it will actually come through and look for any methods that have a test method attribute, and it'll run all of those. So if I save all of these and I go to test and I open up the Test Explorer, a window will open up, and you see that we can run all, or we can run failed tests, not run tests. There's a number of options. We can create playlists for our tests, but I'm going to click run all. And so when you run all, it will build your solution. All the projects will be compiled, and then it runs a test, and we see it should add 2 plus 2, ran in 5 milliseconds, and we can also see that it passed. So what that tells us is that yes, indeed, add 2 plus 2 does in fact work. The next step is then to write a series of tests. I'm going to just cut and paste some samples in. And here I'm going to test the divide by the divide functionality, just with a regular division of dividing 9 by 5. Here I actually calculate a result. I could have done it by hand, but at least I'm not using the class to figure out what this result is. I'm figuring it out separately, and otherwise it's structured the same way. So this will check to see if it can divide 9 by 5. I also want to see if I can catch a divide by 0. So here, expected result should be true, and I'm checking the divide by 0 property to see if it'll actually figure out a divide by 0. So if I save all that and run all these tests, and the last one was should not catch divide by 0. So here I have 9 and 3, and that should return false. So I'm testing that functionality. And I run all the tests, and they all work. So why do this? These seem like pretty trivial tests. Well, the thing is that once I now have this test project, if this code gets changed, I can, if I run these tests automatically, I don't have to go in by hand and verify that nothing was broken by the changes. This will ensure that my configuration is still solid and that my classes still yield the returned results. And typically what we do is we should write our unit tests based on the requirements from the user. And if you use the test-driven design approach, you will actually write these tests first and then write your code. And that way you only build what the user requests, and you test it as you go along. This completes my demonstration. Thank you very much.